Hello, guys. This is Tiago, and I'm going to talk to you about React basics. The idea here is to give you a little bit of a primer on React for those of you who are already, front-end developers who already know your HTML, your CSS, your JavaScript. Maybe you work on a different framework like Angular or whatnot, and you want to check out React. So this presentation is for you. So let's get started. What I'm going to cover today is I'm going to give you a little bit of a introduction on React. Then I'm gonna take a more in-depth look into React, give you like some code examples and things like that. Then we're gonna talk about Redux and what it can do for us, and then finally we're gonna finish with a presentation on how to integrate React and Redux. All right. So what is React? How does it work? And why use React? Let's cover each of those separately. So first, what is React? So according to the React website, React is a JavaScript library for building user interfaces. My definition of React is a little bit more specific maybe, or a little more low level. I like to call React a library for structured manipulation of the DOM. Notice that both of us use the word library for React instead of framework. And the reason for that is the React is actually very specific. It doesn't do a lot for you. It's a single purpose component. So it's all about just manipulating the DOM. So it's closer to something like jQuery, which is focused on DOM manipulation, rather than something like Angular, which provides a lot of services like a URL router, a data bindings library, a model library, stuff like that. So React is a library. The React official documentation used to call React the V in MVC, but I suppose they changed that because it's not very accurate. While React is indeed used to create the view portion of your application, it is not really the V in MVC because the MVC typically is a design pattern used in object-oriented applications, and actually React is typically not used in object-oriented design, right? So React applications typically use more of a functional paradigm instead of an object-oriented paradigm. We're going to see what that means a little bit later. But also, in fact, in colloquial speech, React tends to be referred to as a framework, I suppose, way more often than a library. And the reason for that is that there is this whole ecosystem of third-party React and React-related packages that offer all those services that you typically find in other frameworks. So for example, there is something like React Router, which is a URL router that was designed to be used in conjunction with React. It's similar to what you find in something like Angular, right, which provides its own router. Also, Redux can be thought of as a component that's part of the React ecosystem and perhaps the most important one. All right, so how does React work? So, in a nutshell, React works sort of like this. You have a bunch of components that receive data as input. In that sense, it's a one-way data binding. They're receiving data as input, and they are spitting out a tree of elements into what is called a virtual DOM. So differently from other libraries and or frameworks in which the output, the tree of elements that's outputted goes directly into the browser's DOM, in React, the tree of elements is actually written to a virtual DOM, which is a basic in-memory data structure. They're not immediately outputted to screen. So what React does is it takes the tree that's in the virtual DOM and compares it to the tree of elements that's in the actual browser DOM. And then it only modifies the DOM in those specific spots where there are new elements. And the reason for this is to achieve higher performance, because modifying the DOM is actually a really expensive operation. So that's pretty cool. So, but why do we use React then? Well, I'm going to give you some reasons approximately in the order that whichever makes me the happiest. So the thing that I like best about React is that of all the front-end libraries that I've worked with, it seems to be the one with the lowest cognitive load. What do I mean by that? Well, React, compared to something like Angular or I don't know, maybe Backbone or Ember or or I guess even jQuery, it has a very small API, and because of that, I actually don't have to juggle many concepts in my head to be fluent and productive while working with React compared to other libraries. Also, because of the virtual DOM, React is very lightweight. It has very high performance. And since React is just a library, it is very unopinionated. It doesn't mandate a specific project structure. It doesn't require you to put the files in a specific directory structure. It doesn't require you to use specific names for your component. It doesn't require you to do any of that, which is something that frameworks like Angular and I guess especially Ember require you to. And I tend to prefer the more unopinionated types of frameworks. Another thing that's very cool about React is that it is very independent of the browser. So 99% of the time you use React to create front-end applications for the web. But you can also use React on the backend on the server to generate web pages. And you can also use it in mobile applications as React Native, because whatever the components generate, like the structure that's generated by rendering the React components, it actually does not need to be HTML. It can be anything that can be represented via sort of an XML type of structure. So you can generate, for example, SVG with React, or you can generate textual HTML on the server, or you can generate a structure of UX components in a mobile application with React Native, for example. So it is very flexible in that sense. It is rendering technology agnostic, so to speak. All right, let's take a better look into how React works, how do we use it, and whatnot. So first off, what are components? So a React component, technically speaking, is just a node in a hierarchical structure. The children of this node can be other components or can be typically HTML elements. And the great thing about components is that they are composable, right? Since they are just nodes in a random tree, you can build trees of arbitrary size and complexity. And you can also reuse components because they can be rendered as many times as you'd like in as many different places in your hierarchy as you can possibly think of, which is pretty cool. So this is the view that you have to have in your mind when you think about components, right? You have this root component, and then it has all of these other components as children, and then they may have HTML elements as children as well. So it is a very flexible model. You can build an arbitrary tree as a component, and components themselves are subtrees of arbitrary complexity, so they can be infinitely composed to build an application that basically does whatever you want it to do. Now, if you compare components to a similar technology that's used in front-end development, which is templates. Templates are much less flexible. They're all about manipulating text instead of actually manipulating objects in a tree. And because of that, templates are much less composable, right? It becomes a lot trickier to render, for example, render a template in multiple different arbitrary points of your web view compared to a component which is naturally composable. Uh, it's similar to, for example, if you're a compiler guy, to what's called a hygienic macro versus a regular macro like in C. So C macros are all about manipulating text. So using C macros is actually very tricky. You have to protect yourself with all sorts of parentheses and stuff like that to make sure that the C preprocessor is actually not replacing text in generating text in your file that will lead to a syntax error or even worse, incorrect code. So with hygienic macros, it's the same as a component here. You're directly manipulating the abstract syntax tree, thus basically being able to be infinitely composable with your macros. Same with components. This for me is actually the key insight of React. Okay, so another thing that's interesting about React is that it's typically used with this JSX syntax. And what JSX is basically this, right? It's basically JavaScript, but you can basically create tags inside your code. That's about it, you know. It's essentially JavaScript, but it has the syntactic sugar to make it easier for you to create and instantiate HTML elements and other components in your code. Like I said, it's JavaScript, and it has XML as its first-class citizen, and it uses that fact to create a declarative syntax for component hierarchy. So for example, here we're rendering the root component of our application, which is this hello message component, and it's declarative. You just have to mention it in a tag and it's instantiated. It's as simple as that. But JSX comes with some caveats. So when you're defining a class for an HTML element, you actually have to use class name instead of class. And the reason for that is that class is actually a reserved keyword in JavaScript. Something similar needs to be done for event names. So for example, here with the onClick event, you actually have to use this camel case form instead of the all lowercase form that's used in regular HTML. Something to keep in mind when writing JSX. Okay, so let's talk about components in further detail now. So there are two types of components, class-based and functional, and we're going to take a look at both of them now. So a class-based component looks like this. You declare a JavaScript ES6 or ES 2015 class that extends React.component. In here, we're calling this render method, which basically is the method that's going to return the instantiation of the subtree of components and elements that this component generates. So in this case, hello message just returns a div with the hello somebody whose name I'm getting via a prop. We're going to discuss props later, but props are basically the inputs of our component. Now, the same component in a functional form is just a JavaScript function that receives an object for the props. So instead of having the props available as one of the class's attributes, a functional component receives props through its first argument. And in here we use the ES6 deconstruction syntax to retrieve the name from the props, thus leading to a much cleaner syntax, much cleaner code. Okay, let's talk about props then. So props are properties, if you haven't noticed already. They're the inputs of a component. They're passed on to a component by its parent component. And something that's very important, props are read-only. You cannot modify props inside the components that's receiving them. However, components also may have what's called state, the internal state of the component. You can only use internal state in class-based components. And using state actually makes your component impure because the output, like the rendered output of your component, no longer depends exclusively on the input props that it's receiving. That makes it impure. Also, state is handled in an asynchronous fashion. So to modify the state of your component, you actually have to use the this.setState function, and that does not immediately modify the state. It's actually an asynchronous modification. So here's an example of a state change. We have this name input, and let's assume it's something like a form or something like that, and you have an input that for the event on change is actually calling this handle change handler function. So it will receive the change event, and then it will change the state. It will change the name attribute of the state to the target, to the value of the target of the event. So if you change the value that you have typed into a text box, this will generate a on change event that is going to call this handler, and then the new name is actually going to be propagated to the component internal state via this call. All right, components also have what we call a life cycle, and you only have access to this, to the lifecycle callbacks that React gives you if you're using class-based components. So let's take a look at the most typical lifecycle callbacks and functions and how they happen and why do you typically want to use each of them. So the constructor is just the ES6, ES 2015 class constructor. It's not specific to React. Typically you use the constructor in a React component to set the initial state of the component and also to bind some of the component's internal methods to this. Let me show you. This is a component for a to-do item, and here is its constructor. So first of all, we're setting the internal state of the component to have the completed flag set to false. Notice that we have this handle click internal method that's probably a handler that's going to be called in the onClick event of some HTML element. But remember, ES6 classes do not typically bind the internal methods to this, and because of that, the most idiomatic way of having them bound is actually by binding them in the component's constructor, like I'm doing right here. So I'm changing this dot handle click to be this dot handle click bound to this. Cool. Now the render method. The render method is actually called every time a component will render or re-render. And it will return the subtree of child components or HTML elements that this component will generate at render time. Here's an example. So for a to-do item, rendering will return a list item with a class name of to-do item and an internal text of this.props.description. So it's getting the description of the to-do via a prop and rendering that as the internal text of a list item. Pretty straightforward. Component did mount. This is a lifecycle callback that will be called only once, right after the first render of the component. You typically want to use it to perform some sort of setup that requires the component to be in the DOM. Like it requires the actual HTML elements generated by your component to be already present in the DOM. For example, when you want to set up event listeners. Also, typically, we don't want to call this.setState inside component did mount because this will actually trigger another render. Even though React tries to optimize for this scenario, it's best that we don't do it. Here's an example of a good use of component did mount. Here we have a clock component, and let's imagine this clock component is actually an analog clock, and we want to create a set interval for an internal method that will update the position of the clock's hands. So we set this set interval in component did mount to update hands, and we want this internal method to be called every 1/25th of a second. So basically you're going to be updating the clock's hands 8 times a second. Component will unmount. This is called when the component is going to be removed from the DOM, when the component is going away. And typically we use it to perform cleanup for those elements or event listeners or things like that that we may have defined in, for example, a component did mount. So going back to our clock example, here we have it again, and in component will unmount, we're going to clear interval for that set interval function that we defined. Pretty straightforward. Another lifecycle method that's used fairly often is component will receive props. This is called when the component is receiving new props. And typically we want to use this callback to update the component's internal state with the new props that are being received. Let's see an example. So here we have a component that's called high score. Imagine we have a game And we have this component called high score that's going to display the highest score that has been achieved in the game so far. So you receive the game's score via a prop. And in component will receive props, we get the next props. And we have this logic. So if the score that we're receiving is actually greater than the present score, then we want to set state with the new high score being the score that we're receiving as props. This way, this component will always display the highest score that we have received so far via the prop. Very cool. Okay, this finishes our introduction to React. Now we're going to discuss Redux a little bit. We're going to investigate what is Redux, what are its three core principles, what are the advantages of using Redux, what are the parts, the component parts of Redux, and how does its data flow work. So what is Redux? Redux is a centralized, immutable state store for application. Basically, it is a library that provides a way to store your entire application state into an immutable data structure. Here are the three principles of Redux. Redux is meant to be the single source of truth for your entire application state. The state of your application in Redux is supposed to be read-only. You are not able to mutate it directly. And third, the changes that are made to your application state are made with pure functions. So what are the advantages of working with this model? First off, it's actually easier to reason about. You don't have to be hunting through many places of your code or many places in your components or even like your debugger or something like that to be able to find where a certain portion of your application state is stored. With Redux, everything is stored in the only one Redux store. Also, this design, because it is so functional, like based on functional programming tenets, it is much more testable because you can just take your present state and give it some inputs and then receive the next state. And you can just test that very easily in unit tests. Also, because Redux stores your entire application state in a single data structure, it becomes much easier to save and load your application state to make it resume to wherever you were doing in it. Also, because it encompasses your entire application state and it is immutable, it becomes much easier to implement undo and redo in your application. Because since every operation in your application is going to generate an entire new state, you can just save the sequence of states that your application is going through, and then you can just go back and forth in this list of states. This is also used to implement a feature that's become very popular with Redux, which is time travel debugging. The ability of actually being able to go back and forth in your application state to try and reproduce essentially its many states and help you in debugging. Here are the components of Redux. You have state, you have actions, you can also have action creators, you can have reducers, and of course you have the Redux store. Let's take a look at each of them. So state is something very obvious. It is a plain JavaScript object that describes the state of your entire application. It can be anything you want, as long as it makes sense for your application. Now, actions. Actions are also plain JavaScript objects. And what they do is they describe state transitions in your application. There is this standard called the Flux Standard Action, and it basically describes what is the preferred structure for this plain.js object. We're going to examine the standard a little bit further. Because some of the actions, like the objects that describe the state transition of your application, in some applications, those objects may end up being quite complex. Because of that, it is very idiomatic in Redux to use what's called action creators. Action creators are pure functions that are used for convenience in those applications, and what they do is they construct and return those action objects for you. So in a lot of situations, you have to construct a fairly complex action object, but you don't need a lot of data to actually construct this object. So in those scenarios, you should definitely use action creators to construct the object for you. Here's an example. So we have this add to do action creator. To create the action of add to do, all it needs is to receive the description of the to do as an input, as an argument. And what it generates is this action object that has a type of add to do and a payload of the to do's description. Also, it's important to mention that this action that is being generated here follows the Flux standard action specification, in that it has a type attribute that is a string, and strings are very desirable here because they're easy to be serializable, and it also has a payload field that has an arbitrary JavaScript object. Okay, so reducers. Reducers in Redux are pure functions that receive two arguments: the current state and an action describing a state transition. And then the reducer returns the next state as output. And typically in Redux, because since it has a single store that contains the state for your entire application, it typically wants to deal with a single reducer that will take the current state of the entire application and an arbitrary action, and then return a new state for your entire application. This is typically called the root reducer, and it's received by Redux when initializing your store. A typical responsibility of your root reducer is to return the initial state of your application. So it is idiomatic in Redux to have your root reducer to, when it receives undefined as the current state, to actually return the initial state of your application. And Redux actually does call the root reducer with undefined to retrieve the initial state of the application. Also, in applications that are very complex, typically it becomes very difficult to write a single reducer for the entire application and use that as your root reducer. So in those applications, typically what's done is many different reducers are written, each with a very specific set of responsibilities. And then since all those reducers are pure functions, we actually use function composition to generate this one master root reducer, which will then pass on to Redux. So here's an example of a reducer. Since this is a really simple application that only has the add to do action, we don't use function composition here. Well, here is how a reducer is typically presented in Redux. So it receives two arguments as we discussed, the state of the current state of the application and the action that represents a state transition. Note here that we use ES6 default arguments to initialize the state of the application. Since Redux is going to call the root reducer with undefined as the initial state in order to receive this initial state of the application, it will actually use empty list as the initial state of the app right here. This form of default arguments in reducers is very idiomatic in Redux applications. So in our reducer, another thing that is highly idiomatic is to use a switch statement on the action type. Here, we treat the action type of add to do. And what do we do to add a new to do to your list of to dos, which is the application state? First off, we construct the new to do object which consists of an object with two fields: description, which we grab from the action payload, and completed, which describes if the to-do has been completed or not, and the initial state for the to-do is set to false. Now, since we actually cannot mutate the state of the application by using something like the push method in the array, we actually have to return an entire new array that is going to substitute the previous state of the application. In order to do that, we use the ES6 splat syntax to create an array with every single object that's already present in the current state, plus the new to-do concatenated to the end. And notice that another thing that's very idiomatic of Redux reducers is to use the default case in the switch for cases where you don't know how to handle the action type. Remember, Redux is going to initially call this root reducer with undefined for both the state and the action, and in that situation the default value is going to be assumed for the state, and we're going to go straight to this branch of the default branch of the switch, in which we're going to return that state, which is empty list. This way you see the code flow for generating the initial state of the application as an empty list. Alright, let's discuss the Redux store. What is the store that is made available by Redux? So the store is responsible for storing the entire state of the application. It is immutable, and it provides the following API. So first off, when you're going to create the store for your application, you call the create store function of Redux and you pass it the root reducer as its only argument actually. Then that returns a store object. And this store object has three main methods in its API. The first off is getState, which returns the entire state of the application. The other is store.dispatch, to which we pass an action object. And store.dispatch is actually going to dispatch this action to the store, thus triggering a state change, a state transition in our application. Also, we have the store.subscribe method, which is for listeners of the store. And here we basically register listener callbacks to the store that are going to be called every time the store goes through a state transition. So this is how Redux gets integrated in your application. The various elements of your application are actually going to subscribe to state changes in your store by registering a listener via the store.subscribe method. So when a state change happens in your store, they can actually update, for example, views of your application by, via the listener callback that has been registered. Also, when an element of your application wants to modify the state of the application, you will call store.dispatch with a specific action to produce a state transition in the application. Furthermore, store.subscribe actually will return a function. And if this function is called, it will cause that listener to be unsubscribed from the store. Alright, so how does data flow happen in Redux? Redux has a strict unidirectional, one-way data flow. First off, there is a call to store.dispatch with an action. Redux will then call the root reducer, passing the action that was received via the dispatch method. The reducer is going to then return the new state of the application based on the previous state and the action that has been received. And Redux is going to save that complete state tree that was returned by the root reducer in the store. Right afterwards, Redux will call every listener that has been registered with the store and send to them an event. Call the listener callback with the state changes. Okay, so how do we integrate React and Redux? We're going to discuss the React Redux package. We're also going to brush up on presentational and container components. And we're going to look at a few methods that are provided by the React Redux package, like connect and the provider component. Let's check it out. So React Redux is a package that helps integrate Redux in a React application. It provides a series of helper functions and bindings that help you be able to pass the Redux state, connect the Redux state to React components. Using React Redux is actually higher perf than just calling store.unsubscribe by hand. And because of that, you should always use this package when integrating React and Redux. So what are presentational components? In a React and Redux application, it is very important to write presentational components because these components are easy to integrate with the Redux store. So what are those components? Presentational components are called dumb components as well. And what that means is that they don't contain any logic in them that allows you to read or modify the state of the application. They don't call Redux themselves, they just get the data from props and then they perform changes by invoking callbacks that they also received from props. So they've just received this opaque callback as a prop and they call it. And supposedly this callback, whoever's feeding it to the presentational component, has defined a callback that is actually going to call into Redux and do all the state changes and whatnot. And these are what's called container components. So container components, like I said, they do contain logic to read or modify state by calling into Redux dispatch, for example. They, however, are not created by hand by the programmer, and they're instead created by calling the React Redux function connect. These components will do for you the magic of subscribing to the Redux state and also dispatching Redux actions to the appropriate store. So how does this work? You actually make this connection. You actually generate a container component by calling the connect function from React Redux. The connect function takes two arguments, which are also functions. They are called map state to props and map dispatch to props. So what map state to props does is it receives the state of the store and actually returns an object or a function that returns an object that will map the state of the store to props in the present to the props of the presentational component that's being wrapped. Map dispatch to props will receive the dispatch method of the store and will actually return an object that will map props of the object to functions that are going to cause action dispatches. Here's an example to illustrate what I mean. So we're creating this container component called todos container for this presentational component called todos, which supposedly is a list of to-do items. You'll receive two functions, map state to props and map dispatch to props. So map state to props receives the state of the application and will return an object that maps the state to the props that will appear, that will be passed to the todos component. So in this case, the todos component is going to receive a prop called lowercase todos, whose value is actually the entire state of the application, which, if you remember, in our previous examples of a to-do application is just an array of to-do items. Now map dispatch to props is going to receive the dispatch method of the store, and it will return this object that will map will generate props whose names are those keys and whose values are these callback functions that will cause actions to be dispatched. So for example, in this specific case, the todos component is going to receive a prop called onToDoClick, which is a function that receives an ID parameter and causes a dispatch of an action that is generated by the toggle to do action creator receiving an ID. Also, it's interesting to note that this form illustrates how important it can be to use action creators instead of just creating actions by writing object literals by hand. If we actually had written a toggle to do action object literal here by hand, it would have made the code much harder to read. You would actually have to create an object with a type parameter of toggle underscore to do all caps. Also, it will need to have a payload with the ID and whatnot. So that would be an extra 3 or 4 lines of code here. It is much more compact to use action creators, and that's why they're so idiomatic in Redux. Another thing that React Redux gives us to make our lives easier integrating React and Redux is the provider component. So the provider component is a special wrapper component that will inject the store into all the container components in your application. And the way to use it is to actually wrap the application's root component with it. So here's how you do it. So we have this application whose root component is called app. Here we create a Redux store by passing it the root reducer to the create store method. So the way we actually inject the store into all of our container components is by wrapping the app, which is the application root component, with this provider component with a prop of the store. So basically you pass the store as a prop to the provider component, and it will inject the store to every one of its child components. In this case, it will be the application root component. So that's it, folks. We have taken a cursory look at all the conceptual elements of both React and Redux. These are the basic concepts that you need to have in your mind when creating and working with React and Redux applications. In a further video, I am going to do a live coding of a simple React and Redux application. It's actually going to be a to-do application. And this following video is actually going to be very important because it will showcase lots of things that are very idiomatic in writing React and Redux applications, plus lots of patterns and maybe even special packages that are commonly used and that I may have not have had time to cover here in this presentation. So thanks for watching, and if you have comments or questions, feel free to add them in the comments below. Thank you very much.